Hi, in this video I'll be presenting our final project for the combined cycle power plant power output estimator. Together as a group we worked together to make a scikit-learn model and to help predict stuff. In this video I'll walk through everything we coded and we completed as a group. To start, we loaded the combined cycle power plant dataset. It contains 9,568 rows and 4 input features, temperature, vacuum, pressure, and relative humidity. The target output is power generated in megawatts. Here we use df info to confirm there are no values, and df describe gives us summary statistics to help us understand the distribution of each feature. Next, we performed exploratory data analysis using a correlation heat map. This shows how each of the 4 inputs relates to the output power. We can see that temperature has a strong negative correlation with power output, vacuum has a strong positive correlation, and pressure and humidity have weaker correlations. This confirms that a linear model is appropriate for this project. We then separated our inputs and outputs. Next, we normalized all the features using their means and standard deviations. We normalized because gradient descent converges faster and more reliably when all features are on a similar scale. Before training the model, we added a bias column of 1s and initialized all model parameters to 0. We also set the learning rate and number of iterations for gradient descent. This is the cost function. It computes the mean squared error between the predicted and actual values. Gradient descent works by minimizing this cost. This loop performs gradient descent. At each iteration, we calculate the predictions, compute the error, calculate the gradient, and update the theta values. We also store the cost at every step so we can check whether the model is converging. This plot shows that the cost decreases over time, which means our gradient descent algorithm is successfully converging. To compare our manual model, we also trained a linear regression model using scikit-learn. This gives us a benchmark to measure how well our gradient descent implementation performs. Here we calculated the mean squared error, the root mean squared error, and the r-squared value. The scikit-learn model performs very well with low error and a high r-squared value, high r-squared score. Here we test our manually built model on the same test set. The performance is very close to the scikit-learn model, which confirms that our gradient descent implementation is correct. We also created a prediction function. It takes 4 ambient conditions, normalizes them, adds the bias terms, and returns the predicted power output using the trained theta values. These are the 5 ambient conditions required in the assignment, and here are the predicted power output based on the manual model. In summary, we analyzed the dataset, implemented linear regression manually with gradient descent, compared it with the scikit-learn model, and created a prediction tool that estimates power output based on ambient conditions. Thank you for listening and watching. During this project, Jacoriyan, Hudson, Jamar, Shield, and I were working all equally. We always scheduled times to meet in the library and work on it in person. So we couldn't really break down each part of who did what, but we all worked on it equally, and we were all working on the same computer at the same time, just giving ideas.